What is a life table?
A life table is a statistical chart of mortality and survivorship of a group of people. Also called a cohort, of the same age at each stage of life. The results are usually shown as the probability of death and survival, as well as the life expectancy at various ages. There are two basic life tables, or expectations of life charts. A current, period or cross-sectional, life table is based on age-specific mortality rates for a given period, either a single or many years. It assumes that as a group ages it has a set pattern of age-specific mortality rates that never change from year to year. But this is based on a hypothetical model of mortality, not the true mortality of the cohort. In a cohort, longitudinal or generation, life table, the people in the group are well defined. Usually of the same age, such as all the people are born in 2000, and have common experiences or exposures. Thus, it is based on age-specific mortality rates that allow for known or projected changes in mortality in later years. If the group is followed up for the incidence of diseases, for example, such as osteoporosis or heart disease development, it is called a cohort or prospective study. To compare, a current life table of life expectancy at age 65 in 2000 would be worked out using the mortality rate for age 65 in 2000, for age 66 in 2000, for age 67 in 2000, and so on. A cohort life table of life expectancy at age 65 in 2000 would be worked out using the mortality rate for age 65 in 2000, for age 66 in 2001, for age 67 in 2002, and so on. But note that not all cohorts are used in mortality studies. Some are also used for other reasons, such as a professor following a cohort of students who study together for the length of a certain degree program.
What are proper and improper fractions?
The word fraction to most of us means a part of something. In mathematics, it represents a type of numeral. In most cases the quotient of two integers, with the top number called the numerator, the number of parts, and the bottom number the denominator, how many parts the whole is divided into. Written out, the numerator and denominator are separated by a slash or dash. A fraction is usually denoted by a/b, in which a and b are whole numbers and b is not equal to 0. For the explanation of why you cannot divide by 0, see above. A rational number between 0 and 1 can be represented by fractions, by the division of two numbers. If the quotient is less than 1, such as 1/2 or 2/5, then it is called a proper fraction. If the quotient is greater than 1 or, in other words, if the numerator of a fraction is larger than the denominator, such as 23/7, it is called an improper fraction.
Why are populations important to statistics?
A population is the entire collection of items from people, animals, and plants to street numbers and various other things of any size from which the statistician collects data. These data are of particular concern because in most cases the statistician is interested in describing or drawing conclusions about the population, also called the target population. For example, take a population of 10 cats. None of them are identical, but certain common features between the cats can be measured, such as color, fur length, and weight. The data collected about one of the common features, such as the fur length of the 10 cats, would be defined as the population.
How is the term inverse used in arithmetic operations?
Inverse operations are those that undo another operation. In particular, subtraction is the inverse of addition because a plus b equals a. Division is also the inverse operation to multiplication. The inverse of a number can be expressed as follows. The additive inverse of a real or complex number is the number that, when added to a, equals 0. In multiplication, the multiplicative inverse of a is the number that, when multiplied by a, equals 1.
How has applied mathematics changed over the past few decades?
In the past few decades, applied mathematics has made tremendous strides in explaining our world. In particular, with the advent of more powerful computers and their mathematically driven software from linked computers over a network to supercomputers, many disciplines that use applied mathematics have greatly advanced. For example, the use of giant wind tunnels to examine wind flow over aircraft only a few decades ago has been replaced by computer simulation. Now the design and testing of aircraft is accomplished by these simulations, making the expense of building physical prototypes a thing of the past because it is now merely a matter of mathematically drawing the aircraft on the computer in order to test new designs.
Are there more advanced concepts in arithmetic?
Yes, arithmetic can even be more advanced than the ideas mentioned above. For example, higher arithmetic is the archaic term for number theory, which is the study of the properties of integers or whole numbers, 0, plus or minus 1, plus or minus 2. It can include anything from simpler arithmetic concepts to the more complex, such as Diophantine equations. For more information about these equations, see algebra, prime numbers, see below, and functions such as the Riemann hypothesis. For more about Friedrich Bernhard Riemann, see History of Mathematics and Geometry and Trigonometry. There are other more advanced ideas in arithmetic, too. For example, modular arithmetic is known as the arithmetic of congruences, see below. The model theory discusses the existence of non-standard models of arithmetic. And floating point arithmetic is performed on real numbers by computers or other automated devices.
How do you add matrices?
It is pretty easy to add matrices. For example, for 1 2 plus minus 1 minus 2, you add the matrices, or in this case, row numbers, simply by adding the corresponding terms in each matrix. Thus, the matrix of 1 2 plus minus 1 minus 2 equals 1 2 1 2 2 2 equals 0 0. All that remains of the once great Maya civilization are remarkable ruins such as these in the Yucatan Peninsula of Mexico. They are reminders of an advanced culture that had made great strides in mathematics, including the use of matrices. The image bank/Getty Images.
What is a currency exchange rate?
When traveling to another country, it is important to know the currency exchange rate, which is the value of a traveler's home currency compared to the currency of the country being visited. For example, like all currency, the US dollar fluctuates daily when compared to other countries' currencies. If you travel to Canada, and the US dollar can buy $1.40 Canadian dollars, then the exchange rate is 1.40 to 1. If you go to New Zealand, and the US dollar exchange rate is 0.5477, then 1 New Zealand dollar is worth 54.77 US cents.
Is measurement tied to mathematics?
Yes, measurement is definitely tied to mathematics. In particular, the first steps toward mathematics was using units, and eventually numbers, to describe physical quantities. There had to be a way to add and subtract the quantities, and most of those crude calculations were based on fundamental mathematics. For example, in order to trade horses for gold, merchants had to agree on how much a certain amount of gold, usually as weight, was worth, then translate that weight measurement into their barter system. In other words, X amount of gold would equal Y amount of horses.
How did the symbols for long division develop?
In the 19th century, United States textbooks typically showed long division with the divisor, dividend, and quotient on the same line, separated by parentheses. As in 36, 108, 3. In the same century, in examples of short division, a vinculum, line, was placed under the dividend, with the vinculum almost attached to the bottom of the parenthesis.
Where did the symbols plus, plus, and minus originate?
Mercantile arithmetic. Originally, he used the signs and to indicate excesses and deficits. What we would call credit and debit, in business dealings. But some historians believe the and sign initially evolved from the French et or and, because the written e and t resemble the and sign. Although they were probably used before in general mathematics, the first person known to have used the plus and symbols in writing algebraic expressions lived in the early 1500s, Dutch mathematician van der Hoek. The symbols finally went into general use in England when Robert records 1510 to 1558, also seen erroneously as record, book The Whetstone of Wit was published. This is the same book responsible for bringing the equal, smiley face, sign to the forefront of mathematics, see above.
Who was François Veit?
French mathematician François Veit, or Franciscus Vita. 1540 to 1603, is often called the founder of modern algebra. He introduced the use of letters as algebraic symbols, although Descartes see below introduced the convention of letters at the end of the alphabet X, Y, for unknowns and letters at the beginning of the alphabet A, B, for knowns, and connected algebra with geometry and trigonometry. He also included trigonometric tables in his Canon Mathematicus. 1571, along with the theory behind their construction. This book was originally meant to be a mathematical introduction to his unpublished astronomical treatise, Ad Harmonicon Coelest. For more about Veit, see Algebra and Geometry and Trigonometry.
What famous structures were built using mathematics?
Actually, all famous structures needed mathematics, especially in the initial phases of design and construction. Some of the more famous and exceptionally challenging buildings include the Chrysler Building in New York, a steel-frame skyscraper built around 1930 that was the tallest building in the world before the Empire State Building. The Empire State Building in New York, a steel-framed, stone-clad commercial office skyscraper, built in 1931 that rises 1,252 feet 381 meters high, the Eiffel Tower in Paris, France. Designed by architect Gustave Eiffel and built between 1887 and 1889 as a 985-foot 300-meter-tall exposition iron observation tower. And the Sears Tower in Chicago, built between 1974 to 1976, it is a steel frame with glass stroke. Tour standing at 1,450 feet 442 meters tall and is, to date, the tallest building in the United States. Places such as the Monterey Aquarium, built around 1980 with reinforced concrete and made compatible with surrounding waterfront structures, also needed mathematics in order to be constructed. Of course, when one gets down to it, all types of construction require some math knowledge for them to be built, even a modest piece of cabinetry.
How are absolute and relative humidity determined?
Like many other facets of meteorology, mathematics comes in handy when determining absolute and relative humidities. The absolute humidity is the mass of water vapor divided by the mass of dry air in a specific volume of air at a specific temperature. In this instance, the warmer the air, the more water vapor it contains. On the other hand, relative humidity, RH, is the ratio of the absolute humidity to the highest possible absolute humidity, which in turn depends on the current air temperature. Mathematically, RH is often defined as the ratio of the water vapor density, mass per unit volume, to the saturation water vapor density, usually expressed as a percent. The equation for relative humidity is RH equals actual water vapor density / vapor saturation density x 100%. More commonly, RH is thought of as the amount of water vapor in the air at a given temperature in comparison to the amount that the air could contain at the same temperature. For example, if an area is experiencing 100% relative humidity, that usually means the air is saturated with, can't hold any more, water vapor.
What is number guessing?
Number guessing is a game, some say trick. Some people can do number guessing in their heads, as long as the numbers are kept small. Have a person think of any positive integer n, not 0 or any negative numbers, and apply the following steps. For example, a person chooses the number 25 and keeps that number to humor herself. Ask the person to compute 3xn, 3x25 equals 75, ask if the number is odd or even. Odd, if the number is even, tell him or her to divide the number by 2, if the number is odd, tell him or her to add 1 to the number, then divide that number by 2. 75 plus 1 equals 76 halves equals 38, tell him or her to take that number and multiply by 3, then divide by 9. 38x3 equals 114 / 9 equals 12.666. Take that number and multiply by 2, 12.666, x2 equals approximately 25. The answer should be the original number or close to it.
Why is Omar Khayyam so famous?
Omar Khayyam is not as well known for his contributions to math as he is for being immortalized by Edward Fitzgerald, the 19th century English poet who translated Khayyam's own 600 short, 4-line poems in the Rubaiyat. However, Fitzgerald's translations were not exact, and most scholars agree that Khayyam did not write the line "a jug of wine, a loaf of bread, and thou." Those words were actually conceived by Fitzgerald. Interestingly enough, versions of the forms and verses used in the Rubaiyat existed in Persian literature long before Khayyam, and only about 120 verses can be attributed to him directly.
What is Bayes' theorem?
Bayes' theorem is a result that lets new information be used to update the conditional probability of an event. The theorem was first derived by English mathematician Thomas Bayes, 1702 to 1761, who developed the concept to use in situations in which probability can't be directly calculated.
How can people calculate their age and weight on other planets?
It is certainly possible to find a person's age and weight on another planet without actually having to travel there. To figure out weight, one just needs to know the gravitational pull on another planet, moon, or other space body. For example, based on the chart below, if a person weighed 100 pounds on Earth, he or she would weigh 38 pounds on Mercury, 100 x 0.38. A person's age on Earth depends on how many times the planet has orbited the Sun during his or her lifetime. For example, a person 30 years old has traveled around our star 30 times. In order to work out how old a person is on another planet, the person's age has to be divided by the period of revolution, in terms of Earth years. Thus, if the same 30 Earth-year-old person lived on Saturn, he or she would be just over 1 Saturn-year-old, 30/29.5 equals 1.02 Saturn years. On Mercury, the person would be 124.5 Mercury years old, 30/0.241 equals 124.5 Mercury years.
How can a person calculate the amount of carpeting needed to redecorate a room in a house?
Watching remodeling programs on television, visiting someone else's house, or even getting cabin fever in the winter often triggers the need to redecorate from floor to ceiling.
What is a dog's and cat's age equivalent compared to a human?
All animals age at different rates, and our domestic dogs and cats are no exception. Unlike humans, these pets seem to age more rapidly in terms of human years, with both animals being of an age equivalent to about 15 human years by the time they are 1 year old. There are, however, some differences for dogs. Some people have determined an age range depending on the size of the animal. For example, a dog over 90 pounds may only be equivalent to 12 human years by the time it is 1 year old. A dog 51 to 90 pounds is about 14 human years old when it is 1 year old. And dogs under 50 pounds are the equivalent of 15 human years by their first year. These age differences are reflected for the entire life of the dog. Below is a simplified table illustrating dog and cat years and their human age equivalents. Blood carries oxygen to the heart, and if there is less blood, and thus, less oxygen, reaching the heart, chest pain can result. If there is a near complete or complete blockage that cuts off the blood supply to a portion of the heart, a heart attack, myocardial infarction, is often the result. This is why most doctors recommend watching your numbers for total cholesterol, HDL, and LDL for signs of any change.
What contributions did David Hilbert make to mathematics?
German mathematician David Hilbert, 1862 to 1943, contributed a great deal to mathematical logic, as well as mathematics in general. In 1890 his proof of the theorem of invariance replaced earlier work on the subject and paved the way for modern algebraic geometry. By 1897, his algebraic number theory led to many developments in that field. His contributions also included discoveries in number theory, mathematical logic, differential equations, multivariable calculus, Euclidean geometry, and even mathematical, theoretical, physics. Hilbert is most well known for presenting Hilbert's problems, which originally were a set of 23 unsolved mathematical problems that he hoped would eventually lead to many more disciplines within the field of mathematics. His idea worked, as mathematicians attempted to solve the problems. Their efforts led to mathematical discoveries in the 20th century. Although a number of the problems have yet to be solved. For more information about Hilbert, see History of Mathematics.
What are non-vanishing and vanishing numbers?
A non-vanishing number means just what the term implies, a quantity that is non-zero everywhere. For example, in the expression x4 plus 1, the answer will never be 0. Even when x is 0 or a negative number. The answer for the expression x2 is called vanishing because if x equals 0, the expression's answer vanishes to 0.
Why are mathematicians so interested in transcendental numbers?
Transcendental numbers are those that are not the root of any integer polynomial, or that are not an algebraic number of any degree. Thus, all transcendental numbers are irrational. Rational numbers are algebraic numbers of degree 1. The importance of such numbers translates through more than 2 millennia of history. For example, they provided the first proof that circle squaring was insoluble, which is one of the geometric problems that has baffled mathematicians throughout antiquity. Rings are usually named after one or more of their investigators. But such a practice usually makes understanding the properties of the various associated rings difficult for anyone other than the mathematician working on the ring.
What is computational sociology?
Computational sociology is a branch of sociology that uses computation to understand social phenomena. It takes great advantage of statistics to determine trends in data, and uses computer simulation in the construction of social theories. It is also referred to as the study of social complexity.
What is meant by one-to-one correspondence?
A one-to-one correspondence means just what it implies, that the number of objects, numbers, or whatever is the same as the set of other objects, numbers, or whatever. In set theory, the one-to-one correspondence means something different. For more about set theory, see Foundations of Mathematics. Everyone has no doubt had contact with one-to-one correspondence without even thinking about it. For example, there is a one-to-one correspondence of the number 10 to the number of fingers on both hands, 10. Counting a deck of cards is a one-to-one correspondence each number from 1 to 52, representing a card in the deck. When you compare two decks of cards, putting the cards side by side to equal 52 in each deck can also be considered a one-to-one correspondence. Not everything is counted in such a way. For example, when mathematicians want to know the size of an unknown quantity, they put the unknown quantity in a one-to-one correspondence with a known quantity.
How is the amount of rainfall measured?
The amount of rainfall liquid precipitation that falls to the surface is measured by a rain gauge. The most commonly used freestanding rain gauge is a cylinder with increments, most often in inches, inscribed on the outside of the tube. It is put in an area that is not obstructed by buildings, trees, or other tall structures that can impede the collection of rainfall. The rain gauge can also measure snow, but added steps are needed to calculate this. In this case, a rain gauge measures the liquid equivalent of snow. This is why meteorologists will often say that a snowstorm that produces 10 inches, 25.4 centimeters, of snow will have a liquid equivalent of 1 inch. 2.54 centimeters, of rain, or a ratio of 10:1. But this generalization can be tricky. If the weather system is super cold, such as an Arctic air mass over Canada and the northern United States, the below freezing temperatures might create more than 10 inches of snow per inch of rain. Meteorologists often call this the fluff factor, because the snow seems fluffier due to the fact that there is more air between the snow crystals at much colder temperatures. In fact, in very cold air the snow-to-liquid equivalent ratio can be 15, 20, or even 30:1. For more about weather and math, see Math in the Natural Sciences.
What is non-Euclidean geometry?
Non-Euclidean geometry is a branch of geometry that deals with Euclid's fifth postulate, the parallel postulate that only one line is parallel to a given line through a given external point. This postulate is replaced by one of two alternative postulates. The results of these two alternative types of non-Euclidean geometry are similar to those in Euclidean geometry, except for those propositions involving explicit or implicit parallel lines. For more information about non-Euclidean geometry, see History of Mathematics.
Why do so many philosophers study the foundations of mathematics?
There are three underlying reasons why philosophers often study the foundations of mathematics. First, these foundations have always been a part of scientific thought. With the abstract nature of mathematical objects offering unusual and often unique philosophical quandaries. Second, the subject offers a high level of technical sophistication, allowing philosophers to develop connections between models and patterns, laying the groundwork for many other sciences. And finally, the foundations of mathematics provides ways for philosophers and mathematicians to try out general philosophical doctrines in a specific scientific context.
What is the concept of relative frequency?
Relative frequency is actually another term for proportion. It can be found by dividing the number of times an event occurs by the total number of times the experiment is done. In probability, this is often written in the notation RFN, E, equals R/n, in which E is the event. N is the number of times the experiment is repeated, and R is the number of times E occurs. For example, a symmetrical coin can be tossed 50 times, N. In order to find out how many times tails will occur, E. If the result is 20 tails, R, and 30 heads, then the equation becomes 20/50ths, or 2/5 equals 0.4, or the relative frequency is 0.4 for tails. If this experiment is repeated over and over, the relative frequency will eventually get closer and closer to 0.5. Which is the true value that should result when tossing a two-sided symmetrical coin.
What are deduction and induction and how are they used in mathematics?
Deduction in logic is when conclusions are drawn from premises and syllogisms. For more information on these terms, see above. In this instance, a deduction is a form of inference or reasoning such that the conclusion is true if the premises are true. Or, based on general principles, particular facts and relationships are derived. Deductive logic also means the process of proving true statements, theorems. Within an axiomatic system, if the system is valid, all of the derived theorems are considered valid. For example, if it is known that all dogs have 4 legs and Spot is a dog, we logically deduce that Spot has 4 legs. Other examples of deductive reasoning include Aristotle's syllogisms. Induction is a term usually used in cases concerning probability, in which the conclusion can be false even when the premises are true. In contrast to deduction, the premise provides grounds for the conclusion, but it does not necessitate it. Inductive logic generates correct conclusions based on observation or data. But note that not all inductive logic leads to correct generalizations, making the validity of many such arguments probabilistic or iffy by nature. One can see how both these processes work in the scientific world, especially in the scientific method in which general principles are inferred from certain facts. For example, by observation of events, induction, and from principles already developed. Deduction, new hypotheses are formulated. Hypotheses are then tested by applications. And as the results satisfy the conditions of the hypotheses, laws are developed by induction. Future laws are then often developed, many of them determined by deduction.
How are imaginary numbers used in electrical engineering?
Imaginary numbers are used in electrical engineering because complex numbers are an integral part of electrical problems. In fact, there are often more imaginary numbers in electrical engineering problems than there are real numbers. This is because a complex number is a pair of numbers in which one number is real. The other imaginary, or a real number multiplied by the value I, defined as the square root of -1. For more information about imaginary numbers, see Math Basics. For instance, we know electricity flows through an electrical circuit component such as a light bulb. The bulb actually resists the flow of some electricity by doing work or shining thus. The current is real and measured by a current meter. but if the current can't flow through a device, the current becomes imaginary. For example, a capacitor is two pieces of metal that do not touch. Therefore, if one adds a voltage, no real current can flow through it.
What is a kipu?
Quipus, or quipu, in Spanish, were used by the Incas of South America. A quipu is a collection of knotted strings that record certain information. The approximately 600 surviving quipus use an arrangement of knotted strings hanging from horizontal cords. But these knots are nothing like those made by other cultures, they include long knots with 4 turns, single knots, figure-8 knots, and a whole host of other knot types. Historians believe these strings and knots represent numbers once used for accounting, inventory, and population census purposes. There are also researchers who believe the quipus may contain certain messages in some sort of code, a kind of language used by the Incas based on the strings, knots, and even a quipu strings type, usually alpaca wool or cotton, and color. But it may turn out that historians will never know the real story behind the quipus. When the Spanish conquered the Inca Empire starting in 1532, they destroyed most of the strings, believing they might be idolatrous items containing accounts of Incan history and religion.
How can a calculator determine the limit of a sequence?
Here is an excellent way to understand the limit of a sequence by using a calculator. In scientific calculators that include geometric functions, such as cosine, sine, and tangent, a limit is easy to see. Find x1 equals cos 1, then x2 equals cos x1, and so on. Just put the calculator in the radian mode, enter 1, and then hit the cosine key repeatedly. The number will start at 0.540302305, then change to 0.857553215, and keep changing. As it approaches about the 20th change, the amount gets closer and closer to a number that begins as 0.73. This indicates the limit of the sequence is being reached.
What are dice?
Dice are small cubes usually used in games of chance. Each dice is the plural, has 6 sides numbered with dots from 1 to 6. The dots are placed on the cube so that the sum of dots on opposite sides equals 7. The total number of dots on each die equals 21. They are mostly associated with certain types of games, with the simplest involving a player, or many players, who throw, or toss or roll, the dice for the highest sum. Dice have been around for more than 3,000 years, with evidence found in ancient Egyptian tombs, Chinese burial chambers, and the ruins of Babylon. The Greeks and Romans were avid users of dice and associated games, and they have been popular from the Middle Ages on. Dice have been made from many materials, including ivory, bone, wood, metal, and eventually plastic. Not all dice are square. The cube, or hexahedron, belongs to the group of 5 Platonic solids, or solids formed by regular polygons. Thus, other Platonic solids have also been made into dice, including shapes, polyhedra, such as tetrahedrons, octahedrons, and dodecahedrons, which are used for certain types of games. For more information about Platonic solids and polyhedra, see geometry and trigonometry.
How do geologists use angles to understand rock layers?
Mathematics, especially geometry, is instrumental in understanding rock layers. In a branch of geology called stratigraphy, scientists measure angles and planes in rock in order to know the location of certain rock layers and the possible geologic events that affected the layers over time. In particular, geologists measure strike and dip. Strike is the angle between true north and a horizontal line contained in any planar feature, such as a fault, usually caused by an earthquake, or inclined bed, often caused by the uplift of hot molten rock around a volcano. Dip is the angle at which a bed or rock vein is inclined to the horizontal. It is measured perpendicular to the strike and in the vertical plane, as opposed to the strike's horizontal line.
What is Euler's method?
Swiss mathematician Leonhard Euler, 1707–1783, was one of the most prolific mathematicians who ever lived. He developed Euler's method, which is a way of determining the largest divisor of two numbers. For example, if we want to find the largest divisor of the numbers 6975 and 525, we consider one to be the large number and the other the small number.
Why do weather reports sometimes say the humidity is 100% when there is no rain or snow falling?
A reading of 100% humidity usually means there is a high probability that rain will be or is occurring, but not always. It might be 100% RH because clouds are forming. If the RH near the ground is much less, for example, if a relatively dry air mass is in place, there will be no rain at the surface. This is why Doppler radar sometimes shows rain or snow in an area when none is actually reaching the ground.
What is density?
Density, usually abbreviated as D or R, is a mathematical concept used to describe the ratio between the mass of an object and its volume. The actual formula is the density times the volume is equal to an object's mass, or dxv equals m. In the standard, American, measurement system, density is measured in pounds per cubic foot. But in the sciences, the metric system is usually used and density is measured in grams per cubic centimeter, or grams per milliliter. For example, the density of water is 1 gram per cubic centimeter. Lead is 11.3 grams per cubic centimeter, and gold is 19.32 grams per cubic centimeter. Note, in the majority of cases, the higher the density, the heavier it feels to us on Earth.
What is the music of the spheres?
Not only was the Greek mathematician and philosopher Pythagoras of Samos, c. 582 c. 507 BCE, credited as the first to prove the Pythagorean theorem. He also discovered the music of the spheres. He found that the pitch of a musical note depends on the length of the string producing the sound, enabling him to develop intervals of the musical scale with simple numerical ratios. When a stringed instrument is played, if the musician puts pressure halfway along the string's length, he or she produces a note that is 1 octave above the string's note. In other words, the same quality of sound but at a higher pitch. Octaves increase by 1 step each time a string vibrates at twice the frequency of the previous note. This is expressed mathematically as a frequency ratio of 1:2, string octave. Pythagoras recognized other ratios, too, such as the perfect fifth ratio 2:3, and the perfect fourth, 3:4, thus developing the mathematical basics of musical harmony. Pythagoras took music and mathematics a bit further, believing that the musical octave was the simplest and most profound expression of the relationship between spirit and matter. For more about Pythagoras, see below and History of Mathematics. He also taught that each of the known planets produced a particular note, generated by its motion, according to the planet's distance from the Earth. Calling this musica mundana, or the music of the spheres, it was music no one could really hear. He and his followers, called the Pythagoreans, further used music to heal the body and to elevate the soul. Yet they believed earthly music was just a faint echo of the universal notes. Although today it may seem more magic than hard science and mathematics, maybe Pythagoras was right. After all, many researchers believe music does have the capacity to heal a person under certain circumstances.
Who were John Grunt and Sir William Petty?
English statistician John Grunt, 1620-1674, is generally considered to be the founder of the science of demography, which is the statistical study of human populations. In 1661, after analyzing some major statistics of the London populace, he wrote what is considered the first book on statistics, natural and political observations upon the bills of mortality. The bills of mortality refers to the collections of mortality figures in London, a city that had suffered greatly from the outbreak of several plagues. Because the king wanted an early warning system of new outbreaks, weekly mortality records were kept, along with the causes of death. Based on this information, Grunt made an estimate of London's population. That is thought to be the first time anyone interpreted such data. It is therefore considered by some to mark the beginnings of population statistics. Grunt's work influenced his friend, Sir William Petty, 1737 to 1805. He also influenced Edmund Halley, the astronomer and discoverer of Comet Halley. For more about Halley, see Mathematics in the Physical Sciences. Petty's work was a bit more practical and political. He wanted to set up a central statistical office for the English crown in order to make estimates about the sum of England's overall wealth. His unusual approach was to assume that the national income was the same as the total national consumption. He didn't forget about the plague, but added estimates of losses to the national economy due to the plague. From there, he suggested that modest investment by the state to prevent deaths from plague would produce abundant economic benefits.
What is a universal set?
A universal set actually applies to sets that are not universal but are chosen from a specific type of entity, such as sets of numbers or letters. Thus, the set of all the elements in a set theory problem are collectively called the universal set. In reality, however, the set of all things does not exist because there is no largest or all-inclusive set. And so the true universal set is not recognized in standard set theory.
What are median and mode?
The median is considered half the sum of the two numbers nearest the middle. In other words, in an ordered data set, the median is the value at the halfway point, above and below which lie an equal number of data values. But note, there is an actual middle number for a set with an odd number of members, but no middle number for an even number of members. The mode is considered a single value that occurs more often than any other in a set of data. It is not the frequency of the most numerous number, but the value of the number itself. Often there is more than one mode if two or more values are commonly found in the set, often called a multimodal population.
What are the basic Roman numerals and how are they used?
There are only 7 basic Roman numerals, as seen in the following chart. Number Roman numeral 1 I5 V10 X50 L500 D1000 M. There are many rules, of course, to this method of writing numerals. For example, although the way to write a large number like 8000 would be M. This is very cumbersome. In order to work with such large numbers, one rule was to write a bar over a numeral, meaning to multiply by 1000. Thus, 8,000 would be 8 equal to our Hindu Arabic number 8 with a bar over the entire Roman numeral.
What is an algorithm?
The word algorithm is a distortion of Muhammad ibn Musa al-Khwarizmi's name, 783 c. 850, also seen as al-Khwarizmi and al-Khwarizmi, the Persian mathematician who wrote about algebraic methods. For more about al-Khwarizmi, see History of Mathematics. In general, an algorithm is a specific set of instructions that, if followed correctly, will lead to a recognizable end result. Simply put, a recipe is an example of an algorithm. For example, if there are two different recipes for making apple pie, one calling for cutting fresh apples for the filling, the other calling for apples from a can, the end results will be the same, an apple pie. In mathematics, most algorithms include a finite sequence of steps that repeat or require decisions using logic and comparisons until the final result is found, often called a computation. The best example is the long division algorithm, in which the remainders of partial divisions are carried to the next digit or digits. For example, in the division of 1347 by 8, a remainder of 5 in the division of 13 by 8 is placed in front of the 4, and 8 is then divided into 54, and so on. More advanced use of algorithms are found in a type of logic called metamathematics, see below.
What is a caret?
A carat is a unit of measurement representing the weight of precious stones, pearls, and certain metals, such as gold. It was originally a unit of mass based on the carob seed or bean used by ancient merchants in the Middle East. In terms of weight measurement, a carat equals 3 1/5 grains troy. And it is also divided into 4 grains, sometimes referred to as carat grains. Diamonds and other precious stones are estimated by carats and fractions of carats. Pearls are usually measured by carat grains. For more about grains and measurement, see Mathematics Throughout History. Carats of gold are measured based on the number of 24ths of pure gold. For example, 24-karat gold is pure gold, but for a goldsmith standard, it is actually 22 parts gold, 1 part copper, and 1 part silver, as real gold is too malleable to hold its shape. 18-karat gold is 75% pure. 14-karat gold is 58.33% pure, and 10-karat gold is 41.67% pure gold.
What is the pH scale?
The pH scale stands for P, potential of, H, hydrogen, scale. Or the logarithm of the reciprocal of hydrogen ion concentration in gram atoms per liter. In simpler terms, the pH is merely the measure of the hydrogen ion concentration of a solution. The pH numbers are based on a scale from 0 to 14, in which numbers less than 7 represent acidic solutions and numbers greater than 7 represent alkaline, base, solutions. A reading of 7 is considered neutral. Mathematically speaking, once the concentration of hydrogen ions is determined chemically based on moles per liter, the pH value is established by taking the exponent used in expressing this concentration and reversing its sign. It is most often expressed as the notation pH equals log 10H plus. For example, if the hydrogen ion concentration of a solution is determined to be 10 to 4, or 0.0001 moles per liter, the pH is 4. Many people are familiar with the pH scale from high school, especially the practice of using special whitish paper called litmus paper to check for pH. The paper contains a powder extracted from certain plants, allowing the user to determine acidity. The paper turns red. Neutrality, the paper stays white, or alkalinity, the paper turns blue, of various solutions. The stronger the acid or base, the more intense the red or blue, respectively. And pH isn't just for use in chemistry class. For example, it is also important to people who work the soil. All plants need a certain soil pH to grow and flourish, which is why most gardeners and farmers determine the acidity or alkalinity of their soil in order to grow better crops.
What is the component of a vector?
A component of a vector is one with n numbers in a certain order. It is usually listed as x1, x2, xn, in which the numbers within the parentheses are called the components of the vector. Logically, an infinite number of vectors can have the same components. For example, if the components are 3, 4, we know there are an infinite number of pairs of points in the plane with x and y coordinates whose respective differences are 3 and 4. All these vectors are parallel to each other, equal, and have the same magnitude and direction. Therefore, any vector with components of a and b can be said to be equal to the vector a, b.
What are some interesting facts about the Julian and Gregorian calendars?
An interesting fact about the Julian calendar is that it designates every fourth year as a leap year, a practice that was first introduced by King Ptolemy III of Egypt in 238 BCE. A quirk about the Gregorian calendar is that the longest time between two leap years is 8 years. The last time such a stretch was seen was between 1896 and 1904. It will happen again between 2096 and 2104.
What is a polynomial?
In its simplest form, a polynomial is a mathematical equation that involves a sum of powers in one or more variable, all of which is multiplied by coefficients. In such equations, variables and numbers on both sides of the equal sign are considered polynomials. For example, by expanding out the expression, x2, 3, or multiplying out the equation, we discover that x2, 3 equals x3 6x2 plus 12x8, which is a polynomial equation.
What was the Roman calendar?
The first Roman calendar, according to legend, appeared when Rome was founded around 750 BCE. When it actually started is still up for discussion. But the calendar was based on the complexity of the solar-lunar cycles. At first, the calendar had 10 months, starting in March. January and February were added as the calendar was modified. Politics entered into the determination of this calendar, too, with certain officials deciding to add days whenever they desired, and even what to name certain months.
What is the origin of Roman numerals?
Because the history of Roman numerals is not well documented, their origin is highly debated. It is thought that the numerals were developed around 500 BCE. Partially from primitive Greek alphabet symbols that were not incorporated into Latin. The actual reasons for the 7 standard symbols are also argued. Some researchers believe the symbol for 1, I, was derived from one digit on the hand, the symbol for 5, V, may have developed because the outstretched hand held vertically forms a V from the space between the thumb and first finger. The symbol for 10, X, may have been 2 V's joined at the points. Or it may have had to do with the way people or merchants used their hands to count in a way that resembled an X. All the reasons offered so far have merely been educated guesses. However the symbols were developed, they were used with efficiency and with remarkable aptitude by the Romans. Unlike the ancient Greeks, the Romans weren't truly interested in pure math, such as abstract geometry. Instead, they concentrated on applied math, using mathematics and their Roman numerals for more practical purposes, such as building roads, temples, bridges, and aqueducts, for keeping merchant accounts, and for managing supplies for their armies. Centuries after the Roman Empire fell, various cultures continued to use Roman numerals. Even today, the symbols are still in existence, they are used on certain timepieces. in formal documents, and for listing dates in the form of years. For example, just watch the end credits of your favorite movie or television program, and you will often see the movie's copyright date represented with Roman numerals.